Hi everyone, welcome back to my channel. So in today's video we are going to talk about UVM report object. So UVM report object will be very important in order to track the test bench, in order to identify the issues, and in order to debug that particular test bench environment, right? But many we may I haven't seen many videos on this UVM report object. Yes, UVM report object doesn't play much role during your interviews, but in real time it plays a real important role. You will see this UVM report object everywhere within your log file, right? So which is why I thought of making a special video on this UVM report object. And yeah, many students have asked me about this particular UVM report object, which is why I thought instead of explaining it in a message format, I'll do it in a video so that some other students will also, it will be helpful to many other students also, right? Now, before getting into today's video, if you are new to this channel, consider subscribing our channel and hit on the notification bell also. And also, please do share it to all the VLSA aspirants who are learning the UVM, right? Now coming to UVM report object. So you all know that UVM report object is derived from UVM object, and UVM object which is in again derived from UVM void. If you didn't see about UVM void and UVM object, okay, I'll link that video in the description box. You first go check that video and then come to this particular UVM report object. So from this you can see that UVM report object is derived from UVM object, and it acts as a base class for UVM component, right? Now what does this UVM report object actually do? From the name itself you can see that UVM report object is responsible for reporting. Okay, so what does it report? It reports your test bench track process. It report any issues that it has identified during the simulation, or it reports debugs, bugging. If there are any bugs in your particular component or something, it will report that. So all the reporting is done by UVM report object, right? So this is what basically UVM report object do. The entire reporting that you encounter during your UVM test bench development are done by this UVM report object. So what does this UVM report object actually consist of? So whenever any message is to be reported, the UVM report object will be handling it to the UVM report handler. Okay, which in turn UVM report handler will be sending to UVM report server. This is the base mini architecture of UVM report object. Okay, UVM report object will be sending messages to UVM report handler, where depending upon the severity verbosity levels, UVM report handler will be handling those messages and it will be sent to the UVM report server, where UVM report server is the place where all the final formatting and the output displayment is done. Okay, this is what actually the UVM report object is doing. Now if we go somewhat deep into it, what does this actual report handler and report server mean? So the report handler, from the name itself you can say that UVM report handler is the thing which will handle all your messages. Like it will decide whether that message is to be actually printed or it should be omitted. Which message should be printed first, which message should be printed next. So depending upon the priority, it will be sending the messages to the UVM report server. Okay, this is what actually the report handler does. The report handler will be handling all the issues, like what which message should be displayed first, whether it is important or whether it is not important, whether it is a warning, whether it is an error. So all these are done in UVM report handler. Okay, now after handling all these things, if that particular message is to be printed, then the UVM report handler will handle that particular message to the UVM report server, right? Now what does the UVM report server means? Basically UVM report service is the global server. We can say that, like all the messages that are displayed during your simulation, all these are present in this UVM report server. Okay, it's a global server which will take all the messages that are given by the UVM report handler, and then it will format and print that particular messages in the UVM environment. Like all the in the entire UVM environment, it will be printing the messages depending upon the priority and depending upon all the other issues, right? So this is what actually happening during in the UVM report object, right? So in short, UVM report object will be handling or delegated to this particular UVM report handler, which will handle all the messages, and then it will be sending the messages that need to be displayed to the UVM report server, where the UVM report server will be taking all the messages from UVM report handler, and it will be displaying all the messages depending upon the priority and all, right? So this is what happens in the entire UVM report object. Now, as we have already talked about UVM handler, like I have already before we talked that it will handle everything. So how is it going to handle? As I already told you, depending upon the priority, depending upon the issues, so it will handle whether the message is to be issued or not and everything, right? So how is it going to handle, right? Because it should have some inbuilt functions in order to issue, or in order to handle which is first, which in order to prioritize, it should have some inbuilt functions or methods, right? So what are these? Okay, so basically reporting mechanism. So the entire, as I already told you, the entire reporting mechanism is handled by the UVM report handler, right? So how is it going to handle it? So basically it is categorized into three properties. The entire reporting mechanism operates on three important properties. One is severity, second is verbosity, third is action. Okay, depending upon these three things only, the UVM report handler will be prioritizing which is important, which is unimportant, which can wait, which can't wait. So all these things, right? So the first one is severity. So from the name itself, it will say, it will indicate the criticality of the message. So basically, severity means we will be reporting macros. Okay, these are inbuilt, they are inbuilt reporting macros within the severity. Like you'll have UVM info, tick UVM none, tick UVM info, tick UVM fatal, tick UVM error. So all these things are inbuilt functions within the severity. Depending upon the criticality of the message, it will display that particular message, right? So the first thing is severity, second is verbosity. So basically you will be having various verbosity levels, built-in verbosity levels within UVM. Like you'll have UVM high, UVM low, UVM none, UVM debug. So there are, in such a way, there are various verbosity levels within the UVM. So depending upon the verbosity level, it will be filtering the messages. Okay, so this is how basically the verbosity level acts. So after finalizing the severity level and verbosity level, then the actual message will be printed in the sim, defines how the simulator responds. Actual message will be responded in action. So these are the key properties within the UVM report handler. Now let us see individually, like what is severity, what is verbosity, and what is action. So basically, as I already told you, severity is nothing but reporting, they are inbuilt reporting macros within the UVM report object, right? So depending upon what is this actual reporting macro do. Okay, here we are having four reporting macros. One is UVM info, UVM warning, UVM error, and UVM fatal. So these are the four reporting macros, right? So basically, whenever there is any some general information, for example, any information about the component, or any tracking is done, how the tracking, how the progress of the simulation is done, how the progress in the test bench is going done. As before only we have talked about it, UVM report object will be reporting everything, like progress in the test bench, any issues that it faced, debugging, everything is reported by the UVM report handler, right? So whenever there is any general information or any progress in the test bench, all this will be reported by UVM info. So this is the syntax for UVM info. UVM info, ID, message, and verbosity. So basically, the only UVM info reporting macro has these three things like ID, message, and verbosity. Because depending upon the verbosity level itself, it will be printing the message. Because basically, UVM info consists of all the information regarding how the process is being done, how the tracking, it will track everything. We are having lots of components within the test bench like driver, monitor, every component. So it will track everything, right? So because it tracks everything, it will have lots of information, is it or not? Then whenever we want to track particularly something, like how when we want to track some monitor simulation, or else whenever how the particular sequence item is being done. So when you want to categorize it, basically it will be difficult without any this verbosity levels and all. So that is why verbosity level is important in UVM info, because UVM info has everything. So in that everything, if we want to sort out our particular what we are tracking, then we need a verbosity level, right? Hope you understand about it, right? Then coming to UVM warning. So basically, whenever there is any issue, but because of that issue there won't be much problem, but there is an issue, then basically that will be reported by using UVM warning, right? Then if there is any error, obviously it will be reported by UVM error macro, right? And then if there is any fatal error, so basically what is error and what is fatal error? So error means what happens, yes, there are errors, but that doesn't mean it will stop your simulation. It will just show you that these are the particular, these many errors are there in your particular while it is debugging. So it will just increase your error count when it is UVM error. But when it is UVM fatal, basically it will halt or it will terminate the, it won't halt, actually it will terminate the simulation. Okay, so basically whenever there is any severe error which will stop the simulation, then that will be reported by UVM fatal. Okay, so these are the four things in severity level: UVM info, UVM warning, UVM error, and UVM fatal, right? So these are the syntaxes for all these things: ID, message, and verbosity. So basically ID, message, and verbosity is for only info. As I already told you, why verbosity is only there for UVM info? Because UVM info has every message, like it will track entire simulation messages. All the messages in the entire simulation are present in UVM info. So if we want to sort out in that and group of messages, we basically need verbosity level, which is why only UVM info has the verbosity level, and the remaining three will be only having ID and message. So basically ID and message means whatever message that you want to be displayed, that will be coming under this message. Okay, now coming to ID, basically in which component it will be specifying, whether it is a driver component or whether it, ID means nothing but name basically. Okay, in which component you want to print that particular message, or in which place you want to print that particular message, so that is denoted by ID, right? So this is the severity level. Now coming to verbosity level. Okay, so basically in UVM you are having various verbosity levels, like if you see here: UVM none, UVM low, UVM medium, UVM high, UVM full, UVM debug. Okay, so these are different verbosity levels. Okay, basically these are all inbuilt verbosity levels in UVM, and depending upon the threshold value of that particular verbosity level, it will be printing that particular message. It will be sorting out which need to be omitted, which messages need to be omitted, and which need to be kept, and which need to be ignored. So all these things, by depending upon that threshold value that is set, it will be taking everything, right? So now if you see here, let us see basically like what are the things that will be denoted in this verbosity levels. Like if you see here, as I already told you, UN info means it consists of general information. Whenever there is a warning, it is reported by UVM warning. Whenever there is error, it is reported by UVM error. Similarly, in UVM low, UVM medium, UVM high also, we have already, they are already inbuilt things that are sent in this particular UVM low, UVM medium, UVM high. We'll see that, right? Now basically UVM none, if you see that UVM none is nothing but basically whenever there is no, like whenever there is no priority, like it is UVM none means all the critical reports that are like all the reports that need to be displayed without any priority, those are given to UVM none. Means UVM none doesn't, no messages there. So basically any messages that need that doesn't need any priority, or that doesn't need anything, those will be displayed in UVM none, right? Now UVM low, so basically all the messages that need to be displayed less frequently, okay, so these are displayed for UVM low verbosity level. So basically, like a test starting or finish. For example, driver is running. Before writing the code, we'll say that driver component is generated, driver is generated, driver is running, or else sequence item is generated. In that way, simple messages you will see during your code, writing your code, right? So all these messages which are less frequently occurring in your particular test bench environment, those are given to UVM low. Okay, now UVM medium, actually this is the standard default level. Okay, basically mostly all the components that we are running, all the messages in tasks that you are writing, so all this will be given a standard of UVM medium. So basically all the general information that need to be displayed more frequently, not more frequently nor not less frequently, basically everything that we need to be displayed come under this UVM medium. Okay, then UVM high, basically this is given only mostly for monitoring sequences, like the sequences or the data transactions that are gathered from DUT through the monitor. All these things will be given the verbosity level of UVM high. Like we can say that most frequent messages that are tracking the subcomponent activities, like mostly all the messages from the monitors, okay, and then from which are given to the scoreboard for comparison, and also all these things will be given the verbosity level of UVM high. Okay, and then UVM full. So basically if there are any errors, as we have seen that if there may be any errors, or if we are seeing that there are any errors, or any messages that occur that there is some error is going to happen, all these things, so all these things will be given as the verbosity level of UVM full. Okay, and then UVM debug, so most detailed messages for debugging. For debugging we need to have that this is being debugged, this particular component is being debugged, so all these the particular messages are given by using UVM debug. And UVM debug is the maximum verbosity level in this in all the entire verbosity levels. If you see here from top to bottom, the least one is UVM none, the highest verbosity level is UVM debug. So depending upon the verbosity level, for example what I'm speaking here is For example, if you in UVM info, if you are having UVM ID message and UVM debug, then that UVM debug one is the most prioritized one. Okay, and when here there is UVM none, then that is the least prioritized one. Okay, so depending upon the priorities, those message the report handler, if there is UVM debug, then the report handler first sends that particular message to the UVM report server for monitoring. Okay, for example, if there is two levels like low, UVM low and UVM medium. So first UVM medium is displayed and then UVM low is displayed. Clear? This is how the prioritization takes place in messages and displaying the messages, right? So let us see the small example here. Here if you see, this is my driver code class my driver, which is extended from UVM driver. Okay, this we have talked about it, how we are going to write a code class my driver extends UVM driver. I have explained how we are writing this in UVM object. If you didn't see that, I'll link that in the description box and also I'll tag it here. You can just go there and check it out, right? And then we are creating the creating the object. Okay, like tick UVM component utils. You don't worry about this. This we will be explaining in the, this all comes under the factory registration. We will be talking about that in the upcoming session. Don't worry about that. So as for now, just see this particular thing. Just see this particular code. Okay, task run phase. Okay, we will also see this about phases in the upcoming sessions. Don't worry about it. But as for now, if you see, this is the thing that you need to concentrate on. Okay, UVM info, tick UVM info, drive start. Okay, this is the, so ID, this is the ID. So what it will do, it will go to this particular ID and then it will print there the message. This is the actual message, driver execution has started and the verbosity level is UVM low. Now then, UVM info, again UVM info, drive data. Okay, deep debugging, packet data injected. So this is the message for driver data and it is of high level. So now what happens, since this is if you high verbosity level, so first priority is given to this particular UVM high and then the next priority is given to UVM low, right? So again, if tick 1 begin, okay, the simulation begins and then if it is 1, then tick UVM error. UVM error will be it will be reporting as error. So what is the error? You drive photo error, unexpected response from DUT. This is the message actually. Okay, this message is displayed in as an error message. So this is the error message, right? In similarly, this is the fatal reporting. Okay, try fatal clock missing. So what we will do, after it encounters this fatal UVM tick tick UVM fatal, if it is encountering that fatal, then what it will report, it will just display this clock missing message and it will terminate that particular simulation immediately. See, phase drop objection comma this. Okay, so we'll see about what is this phases and all. Phase raise and phase drop we'll be seeing in the upcoming sessions, but this is how you will be reporting the errors. Okay, tick info, tick UVM error, tick fatal, so all these things, this is how you will be reporting that particular messages in your UVM test bench code, right? So this is all for today. This is about the UVM report handler. Hope you understand about this UVM report handler. If you have any further doubts on the UVM report handler, you can ping me in the comment box. I'll definitely reply to you. And also, if you like this video, please do like it and also share it to all the VLSA aspirants who want to enter into design and verification domain and who are studying UVM. Right? So that is all for today. Thank you all.